second question, I'll put that and I'll ask you to do the same steps you can follow. But this is little tricky question, so you can use the first derivative and draw the graph. Of course, we can take the second derivative, but it's a little hard. We'll see. Okay, number 2. Sketch the graph of function. This time radical one. Okay. 2/3, 6 minus 1/3. Okay. So my first question: identify where the extrema of fx. Okay. So please take the derivative and share with me. This is challenging actually, okay? Because the function is a product and it's radical. It's not a polynomial. Can you try that? So what happens if you take the derivative? X to the power 2/3, 6 minus x 1/3. It's totally different graph. Okay, it's not a graph we've seen previously. Previously we had a polynomial. This is radical one. Okay, so with the exponential solving. X 2/3 times the derivative of 6 minus x to the power 1/3.
Do you not take the derivative of the first part?
You can take the first part and keep the second one if you want, or it doesn't matter what you start, where you start. Okay. So you're asking, can I take the first part derivative, and you can do that if you want. Okay. So I just write the first one as it is, and I'm going to differentiate the second part. Okay. 1/3, 6 minus x minus what? You have to subtract this power 1, right? So this minus 1, it's minus 2/3. And is that it? Minus 1, because you have to differentiate inside. Very good. Can I put that minus here? Because I can multiply by minus. Is it clear why I should multiply by minus? Because you have inside function 6 minus x. You have to differentiate that as well. It's the chain rule. Clear? I know sometimes you miss that one. You just think, oh, I'm done with the power rule. No, you're done with the power rule, but you have inside 6 minus x. You must differentiate separately. And if you differentiate 6, it's 0, but minus x gives you minus. If this was like 6 plus x, it's just 1, so you don't want to worry about. But if you have minus, you have to really care. Okay, so this is the derivative, and the second one, you keep the first one as it is. Oh, I'm sorry. You keep the second part and you take the derivative of the first part. Okay, x. I'm taking the power down and I subtract, and I keep this one as it is. So this is 1/3, right? 1/3. I differentiate this part first, and this first part second. You can change if you want. It doesn't matter which one you do first, because it's just plus. Okay. And then what happened? So I'm gonna take the all the negative powers down. So I'm gonna write this one first, maybe 3 6 minus x 1/3 over 2x 1/3. So just write this one, okay? Plus, minus this one. This one would be x 2/3, 3 6 minus x 2/3. Everybody with me? Question, bro. Yeah.
Is there a reason why you switch the 2/3 to 3/2 in kind of derivative of those?
Thank you. Yeah. Thanks for noting. It should be 2 over 3, yes. Thank you. So I should take the power down and subtract. Yeah, power is 2 over 3, not 3 over 2. Yeah. Any other questions? Now, so I'm going to take the derivative here. And I'm going to get the common denominator. 3 is a common denominator. X to the power 1 over 3. 6 minus 2 over 3. 6 minus x to the power 2 over 3. And look at this. So I have only 3x 1 over 3 here, but I have 6 minus x 2 over 3. So I have to multiply that with the top. So I get 2 6 minus x. So let me write down and I'll ask you. So this is just x. So look at this. If you divide this by this, what happens? If you divide this by this, you get 2 over 3. 2 over 3. You get x to the power 1 over 3. So if you simplify this with this, what happens? This is power 1. This is 2 over 3. 1 over 3. You get that. Clear? Minus, what happens if you divide x by x to the power 1 over 3? You have power 1 here, you have to subtract 1 over 3, which gives you 2 over 3. Clear? I know it's tricky when you take the common denominator, but you can see, you can go back to the previous step by considering the separate division. Okay? Now you have denominator is a nice like linear function, so you can think, oh, I'm going to write it like 12 minus 3x. So write one more time this one. Okay. I know this is just an algebra here, but you must understand. So I can cancel out 3, so I can write like this. Anyone has any question how I get the first derivative? I know this is a product rule and you can understand it, and I take the negative power down and get the common denominator. That's the tricky part. And once I get the common denominator, I understand the numerator can be cancelled out with 3 common, okay? And then this is my 4 minus 6. Good. So my first derivative becomes 0 at x equal 1. What happened when I put x equal 4? My first derivative is 0. Clear? So that's my one of the extreme. Clear? Good. You may ask, what happened when x equals 0? When x equals 0, your first derivative does not exist. That means the tangent line is vertical. At 6 also you have same situation. Clear? So 0 and 6 also important point, because at those points first derivative does not exist. Can you see that all information here? So once I take the first derivative, I know 4 is important because at 4 I have a turning point. Maybe it's a minimum or maximum or inflection point. 0 and 6 gives you vertical asymptote. Vertical tangent line actually. Okay? Vertical tangent line. So this is what I'm going to do now. Okay? So I discuss where the decreasing and increasing happen. So 4 is important. But I have only 1.4. But I include 0 from the denominator. 0 and 6. Okay? 0 and 6. What happens if you put negative value to here? Like negative 1 for example. What happens if you plug negative 1? This is positive. Clear, Patrick? Yeah. Clear? Okay. And if you put negative value here, you take a cubic value of a negative number. What is the cubic value of a negative number? Negative. Like negative 8, if you take a cubic root, it's negative 2. So this is negative, and if you put a negative number here, it's become positive again. So it's overall negative, agree? Because the top positive, this part is positive, only this gives you negative. Clear? It should not, you know, you can plug -2 if you want, or if you want to take the cubic root -8. But I don't care the value, I only care the sign, plus minus, so I know it's minus. How about if I plug 1? If I plug 1, this is positive, this is positive, this is positive, all positive. Okay? I'm talking about my first derivative, you know, okay? First derivative. What about if you plug 5, for an example? If you plug 5, this is negative, this is positive, this is positive. So it's overall negative. How about greater than 6? Anybody? Greater than 6? Greater than 6, positive. For an example, if you wait a minute. Greater than 6, like this is negative. This is again positive because you have power 2. Clear? It has a, I mean, you can take the cubic root, but if you take the power 2, it's again positive. Is that clear? Because it's like cubic root and then you take the power 2. Clear? So it's like you take the square. So it doesn't matter you have 2/3, 2/5, 2/7. If you have even degree here, like a power 2 or 4, 6, it's always positive. So this is positive no matter what. This is negative because you put 6 or more, I mean 7, 8 or something like that. So this is always positive because it's a positive number. So overall it's negative. You see, this is negative to positive. So it's like a minimum situation at 0. Right? It's a minimum situation. And this situation is like +2. So this is really the extrema. So I'm gonna mark it like this: increasing, decreasing. This is decreasing, decreasing. Okay. So I'm gonna sketch the graph without taking the second derivative, because this radical function, of course, you can go ahead and discuss this one more derivative, but it takes time. You know. Polynomials is easy to go with the second derivative and discuss all. For this one, I'm going to draw it without the second derivative, okay? Right. 0 is important, 4 is important, 6 is important. At 0, I have vertical asymptotes, so it's going like this, coming like this. Why am I drawing that? I know it's decreasing less than 0. Can you see that? Less than 0, decreasing. Okay. And also I know at 0 I have to have a vertical tangent line. Okay. At 4, I have a maximum. So it's like, this is my 4. I know that. How do I know it's a maximum? Because can you see that increasing and decreasing? Turning point at 0. Okay. At 6, at 6 I have really decreasing and then decreasing. Okay. I'm going to plug my function back to 6 because I want to know where it's happened. Okay. I'm going to plug that 6 here. If I plug 6, you can clearly see it's like 0. Actually, this is 0. So this is really the 0. So it's going like this, and I have like an inflection point really. Okay. So I will draw it my best. It's like going like this. So if you draw this type of, it's like a vertical asymptote, a vertical tangent line actually at this point, not asymptote. Question group, yeah.
So how can you do this graph without doing like the second derivative of
You
doing
can-
concave like we did last time?
You can do it because it's an exponential graph, and taking the second derivative is too tedious, you know, you take time, okay? It's so time taking. But even if you take the second derivative, you may figure out at 6 you have an inflection point. You can do that. You know, it's not a good test question, but it's a good homework question, you know. You can take the second derivative and discuss, and you can verify these informations. But I'm going to tell you, sometimes we can draw the graph without second derivative, okay? Sometimes not. It's not always. Okay? For an example, previous graph, if you just take the second derivative, you would miss that point where the concavity change. This question, you can get all the information using just first derivative. Okay, good. And is it clear? This is like an inflection point, because you see, it doesn't change the sign. It's always decrease. And I know at 6 I have a problem here. My first derivative does not exist. It's all because of I have, you know, like a vertical tangent line. This is horizontal tangent line. Horizontal tangent line, you can quickly see the derivative 0. Okay, so I'm going to write this summarization. Okay, first derivative 0 gives you horizontal tangent line, like this point. I know at 4, horizontal tangent line, because at that point my derivative is 0. If dash x does not exist mean like 0 and 6. Those points I have like, it's called non-differentiable points. At those points, the function is not differentiable. Okay. You can say if dash does not exist gives vertical tangent line. Tangent line is vertical. Right, very good.